Hi everyone. So let's get started. So today we will be seeing joint PDF, joint CDF, and these kind of things. Okay. Mostly we will be basically dealing with the continuous random variable, right? So let's start. So what is a joint distribution? Basically, if we define the distribution for more than one variable, for example, this is just one variable, but what you can do, you can define the distribution for more than one variable, right? This is called joint distribution. For example, maybe two variables, three variables, and so on. Okay. So let's just see some examples. So suppose that joint distribution or joint PDF is given to you, and then they ask you to find out this probability. Then what you will do? See, if only the marginal PDF is given to you, suppose if the marginal PDF, okay, suppose that they are saying that X is between A to B, then how to find out this probability? You will say it is from A to B, f of X, right? Something like this. So you will say something like this. That's how you will find the marginal. Using the marginal, you will do this. But suppose instead of marginal, they will give you the joint PDF. Okay. Suppose this is the joint PDF that they have given you. In that case, what you will do? You will integrate. Let's suppose they are asking you to find out the value from A1 to A2 and B1 to B2. Then you will integrate from A1 to A2 and B1 to B2. Okay. So let's see the examples. And also, if you want to calculate, let's suppose if you want to calculate the marginal PDF, okay, then you can, in case of discrete, what we used to do, in case of discrete, let's suppose PXY is given, and then you just want to find out PY, okay, then you will sum over all the values of X, then it will be PY, right? Something like this. So similarly, if you want to find out, let's suppose, if you want to find out, let's suppose fx, okay, then you will be integrating all the values of y. And similarly, if you want to find out y, then you will be eliminating x, which means you will be integrating for all the values of x. Okay. So now let's just see. See these kind of things. Okay, these kind of things will be involving two integrals, right? So let's just see how to do these two integrals. Okay, and then we will be seeing the examples. So multiple integrals without tiers. Okay, let's just see. So suppose x and y are the two continuous random variable where x is from 0 to 1 and y is from 0 to 2. And we want to integrate, let's suppose something, okay, gxy equal to xy with respect to x and y. Okay, let's see how to do it. So first, what we will do, we will be doing the innermost integral, treating y as constant. For example, if you want to do this, then you will be doing, let's suppose, the innermost integral, and whenever you are integrating with respect to x, treat this y as a constant. If you treat this y as a constant, then this integration of x is x square by 2 and y is as it is, right? And then limits are from 0 to 1. So you put the limits from 0 to 1. It will be 1 by 2. And now you do the integration of this. Okay. So this is just a recap, or this is something that you might already be knowing, but I'm just telling you because we need this double integration again and again. Okay. So that's why let's just see that how to do this double integration. So what to do in this double integration? You do the innermost integration first, and then you treat this y as constant. Okay. You got this, and then you do this integration. Okay. So that's how you will be doing this particular double integration. Okay. So let's now directly see the example. For example, let's suppose the joint PDF is given to you, and now they say that find out the value of the C. See here, the value of X is from, you can say, by to infinity, and value of Y is from 0 to X. Okay. So what you can do, you can, to find out the value of C, you can do the double integration of this fxy, right? And see, if you put the value of x, like, I mean, if you integrate, then basically here you need to integrate with respect to x and with respect to y. Okay, both. And then you will say that this is, if you do it from minus infinity to infinity and minus infinity to infinity, then this is one, right? This is the property of any PDF. If it is joint PDF, then double integration will be one. And like that, we need to find out the value of C. Okay. So let me just go to the next page and let's just try to find out the value of c. Now here, what is the range of x from y to infinity, right? So see, like you might get confused. See here, let's suppose this is y, and let's suppose this I am doing from y to infinity. Okay, that's fine. But you might get confused between this y, right? This is the y, which is basically y is from 0 to x, right? Let's suppose this is from 0 to x. Okay, and y is from 0 to x is from 0 to infinity. So this is your basically integration limits. Now you might get confused between this y and this y. So for example, this is also xy dx dy. Okay. So if you're getting confused, then you can replace this x by x dash or something. Okay, that's fine. Which means like, or maybe you can replace this x by c or c1, c2. Okay, these things are fine. Which means that these are, you can consider this y as some constant. Okay, which means that these are the limits of x, and this x also is a constant, and these are the variables. Okay, these are the real variables. Which means if you're getting confused, then you can put, okay, just to differentiate that this from these limits, you can do this x prime by prime if you want to. Okay, otherwise this is fine. So for example, if you want to integrate, then uh this, okay, first you can do either x or either y, doesn't matter. So for example, if you are doing first y, okay, if you are doing first y, what is the limit of y? Limit of y will be 0 to x. Here x is some constant. Okay, just treat it as some number. Okay, whenever you are doing it, just treat it as some number. Okay, and then this once y is over, okay, once y is over, then the x is freely to choose from 0 to infinity. So for example, if you do this integration from 0 to x, uh, this particular integration, then what you will be getting, let's just find out. Okay. So let's just find out from 0 to x. If you first put the limit of y, if you do the 0 to x, then what is this? Which means integration over 0 to x c e power minus x e power minus y dy. Okay. Okay. Now, let's just solve this. So basically, if you're integrating over y, then you need to treat this particular whole thing as a constant, right? You just treat this whole thing as a constant. So since it is a constant, then what you can do, you can take it outside also, which means this will be c into e power minus x, and then 0 to x e power minus y dy, right? Okay. So what is the integration of e power x? I think it is e power x only. But if it is e power minus y, then it will be minus of e power minus y. So it is same as, you can say this is same as e power minus x, c into e power minus x. Then this is minus of e power minus y, and the limit of y is 0 to x. Okay. Is this fine to everyone? Now you just put this x, and then you just put this y also, this 0 also. So what you will be getting? From here, let's just see that what you are getting. So if you put the c into e power minus x, if you put the x, then it will be minus of c e power minus x. If you put 0, then I think it will be minus and minus, it will be plus, and then it will be 1, right? Okay. So this is something that you are getting inside. Let me know if that is fine to everyone. Okay. So this is 1 minus. So basically you are getting this, which is 1 minus e power minus x, right? 1 minus e power minus x. and c into e power minus x is already there. So now you need to integrate this whole thing from 0 to infinity, right? So from here, you can say you need to integrate this whole thing from 0 to infinity, which is c into e power minus x into 1 minus e power minus x. Okay. Let me know if this is making sense to you. Okay. So now what you need to do, you need to integrate and then you need to plug the values. It will be c by 2. Okay. I'm not going to integrate, but you can integrate. Basically, you need to integrate it. This is a very simple integration. Okay. Just a plus b integration, right? So you can multiply with c into e power minus x. Then you can put the value infinity. E power minus infinity will be uh, what will e power minus infinity? It is e power 1 upon e power infinity, which means it is very high number. So that's why it is 0. Okay. So e power minus infinity will be 0. So you can just integrate it, and then if you integrate, you will be getting c by 2. Okay. So see here, first we have done the integration of y, and now if y is eliminated, then you can say that okay, now since the y is eliminated, and now the limit of x, okay, the limit of x will be from 0 to infinity. So basically, this particular thing, whether y is basically from 0 to x, we have already taken care, right? From 0 to x, we have taken care, and now whenever you are doing the limit for x, since y is no more, okay, in this particular integration, the final integration, in this particular integration, since y is no more, you can integrate from 0 to infinity. Okay. So you can understand like this. See, if this limit is given to you, okay, which is, let's suppose this particular limit is given to you. Let's try to understand this limit. What does this mean? Okay. See, in the 1D or in just one random variable, what we used to do, if there is just one random variable, then I think let's suppose this is uniform distribution. Okay. If this is uniform distribution and the PDF is given like this, okay. Let's suppose this is the PDF. Then let's suppose from 1 to 2 there is a PDF. Can you tell me in the uniform distribution what will be this number? If this is uniform distribution for that PDF, the area must be 1. So for the area to be 1, it should be, I think, if this is 1, then it should also be 1, right? I think it should also be 1. So that the area is 1, right? Okay. Yeah. So this is 1. So what I'm saying here is that if if this is 1D, then this was the values of x. Can you tell me what was this? It was f of x, right? This was the PDF. Is this fine to everyone? If this is 1D, then in case of 1D, we used to have this. Okay. So if there is just one random variable, if there is just one random variable, okay, then we used to do this. Okay. So which means if there is just one random variable, we used to say that, okay, this is from 1 to 2. And based on this, okay, this may be a straight line. This may be, if this is, let's suppose something like this, then the area will be different, right? I mean, what I'm saying here, that if this is just a straight line, then the area is something. If this is, let's suppose something like this, okay? If this is, let's suppose something like this. So based on the fx, right? Based on the fx, obviously the area will be changing, right? So so here, in case of 1D, we used to visualize it. Okay, we can visualize it because the graph will be 2D. If there is only one random variable, then the graph of that PDF will be 1D, 2D, or 3D. Tell me, if there is only one random variable, then graph for PDF is in, tell me, 1D, 2D, or 3D. 1D, 2D, or 3D. So what is the answer? 2D, right? Yes, 2D is the answer. Why? Because one dimension will be taken care by, one dimension will be consumed, you can say, by this fx, and another dimension will be consumed by the random variable x, right? But if you have 2D, okay, if you have 2D, let's suppose this is 2D, then the graph will be in which dimension? In this case, graph of, fxy will be in 3D, right? How it will look like? Let me just tell you. See, it might look something like this. See here, that here one dimension is x, another dimension is y. Okay. So let me just copy that onto the same page, probably. See, what I'm saying here is that currently it is 2D, but let's suppose if we have two random variables, in that case, how will it look like? It will look something like this. Okay, where one dimension, if you notice here, one dimension is one variable, another dimension is another variable. Now there has to be third dimension, and this third dimension is f of xy, right? Is this fine to everyone? So depending on this graph, so basically what we can do, we can say that, okay, x is ranging from here to here, y is ranging from maybe here to here or whatever, right? From let's suppose x is ranging, let's suppose from this to this, y is ranging, let's suppose from this to this. And then what is the area? Okay, what is this area? This is fxy, right? Understood? So here the graph is 3D. That's why it is not easy to visualize. And that's why we will not visualize it. Okay. So hence it is not easy to visualize. Not possible actually. Okay. After 2D, it's not possible. Okay. Let me know if these things are fine to everyone. That's what I'm trying to say here. Okay. So basically, what I'm saying here is that if you have more than one random variable, then the graph will be in 3D, in 4D, like that, right? So that's why we want to be able to visualize also. Okay. Now, what I'm saying here is that, let's suppose your limits are from let's suppose this limits are from 0 to basically y is ranging from 0 to x. So what you can do, you can if y is dependent on x, right? Then you can first integrate over the y, and then you can say that, okay, it is depending on the x, right? From 0 to x. Or maybe if you want, you can first integrate on the x also, and then you can say it is y to infinity. This is also fine. And then once this is taken care, then you can integrate. So basically there are two ways to integrate this. Either you integrate first with respect to y, in that case you will be saying 0 to x. Okay, so this you have to take care of this, right, from 0 to x. And then once this is done, then the x could be from 0 to infinity. Okay, that's fine. Either you do this way, or you do first the integration of, so instead of taking care the limit of y, you can take care the limit of x. So for example, you can say that x is from y to infinity. Okay, once you do this, and then y is from 0 to infinity, right? That is also fine. Okay, whichever way you like, you can do it. Okay, now let's just do something. Let's just solve the same thing using this another limit, which means that, let's just try using the another limit. So we have already done this. Now let's just do some like another limit which we have, which is from 0 to sorry, y to infinity and 0 to infinity. So let's just try doing it. So suppose you do from y to infinity, which is the limit of x, right? C into e power minus x into e power minus y. So since it is a limit of x, you will be writing dx. This is 0 to infinity. This is limit of y. So you will be writing dy later on, right? So what is this differential integration with respect to x? I think this will be same, right? With respect to y, with respect to y, it was minus of e power minus y, right? So anyway, this is easy. So see, you need to integrate this first. So you can say this is 0 to infinity. You can take the c into e power minus I outside, minus y outside, and this is from y to infinity, right? And c into, sorry, e power minus x dx. Okay. This is the integration that you need to do. And once you do this, then you need to do dy. So what is this integration? This is minus of e power minus x. And then you need to put the limit from y to infinity. So if you put the infinity, it will be 0 minus, and minus will be plus. So it will be e power minus y. Is this fine to everyone? Let me know. So I think if you put minus infinity here, then it will be 0. And if you put minus and minus plus, it will put minus. If you put y here, it will be e power minus y, right? So now, since you have got this e power minus y, then you can do 0 to infinity c into e power minus y into e power minus y, right? dy. So which is nothing but c into e power minus 2y dy. Okay. Now, what is this integration? What is this integration? Can you try to find out? It will be, I think, e power minus 2y integration, right? What is the integration of e power minus 2y? It will be e power minus 2y divided by, I think, minus 2. Is this right? Okay. So it will be from 0 to infinity. So you can say that you can take this c by minus c by 2 outside, and then 0 to infinity e power minus 2y. Sorry. So these are the limits. Okay. Now if you put the infinity, then it is 0 minus, if you put the 0, it will be 1. So 0 minus 1 is minus 1. So ultimately it will be c by 2 only, right? So if you notice, then earlier, what is the answer we have got? Okay. Earlier also we have got c by 2. Now also we have got c by 2. Okay. So the answer will remain same. It just depends on the order of integration you are doing. So you can do the order of integration in any way you like. Okay. Either you do x first or you do y first. Is this fine? So see, what I'm saying here is that suppose, sorry, suppose you have this particular integration to solve, right? In that case, you can do it in two ways. Either you do this, or, right? So you do this, or I can say you do otherwise, which means, let me just write it. You do x first. So x will be from 0 to, sorry, y to infinity. So x is from y to infinity. And then y is from 0 to infinity. Okay. So this is x, you can say. First you can write x, and then you can write y. Okay. Either this way or this way. Both is fine. Sorry. So I hope you understood this, right? Now let's just move to the next question. Okay. So this particular, what I'm saying here is that this particular, relation, you can take care of this relation in one of the inequality, right? Either you take care whenever you are doing y. Okay, y is from 0 to x, you can do. and then x is from 0 to infinity. Okay, you can take care of this in any of this inequality. Okay. Okay. Now, let's move to the next question. So what they're saying, suppose that they have given some PDF, some joint PDF, something like this. Now they're asking you to find the value of constant C. Okay. This is some constant C. Can you find it out? So earlier also we did the same question. Okay. They were asking you to find out the value of C. Now also the similar question. Let's just quickly do it. Now here, this x and y are independent, which is also fine. I mean, they are independent in the sense the range is basically not depending on the x or y. So it is 0 to 1 and this is also 0 to 1. So you can quickly integrate and then you can find out the value of c. So if you integrate from 0 to 1, 0 to 1, then if you do this, then c is coming out to be 3 by 2. Okay. So this particular thing, you can just try it as an homework. It is easy only. This A is very easy. Let's just see B. So B is saying that what is the probability from 0 to 1 by 2, and for x it is 0 to 1 by 2, and for y also it is 0 to 1 by 2. Okay. So can you write the probability here? It will be integration, double integration for x also 0 to 1 by 2, right? And then x plus cy square. First you can write dx. For y also 0 to 1 by 2. Then dy, right? Sorry, y also 0 to 1 by 2. Yes, dy. Okay. So I think you can just double integrate it. Okay, from 0 to 1 by 2, 0 to 1 by 2. And then if you do it, then 3 by 32 is the answer. So this is easy question only. You can just try this as an homework. Answer is definitely on the next page. Okay. So now I think now you have understood little bit that how to do double integration and these things, right? Okay. Actually, it will keep on coming. Uh, so let's just solve, one or more example, but don't worry, it will keep on coming. So for example, let's suppose they ask you to find out the value of C. Can you do it again? Just double integrate it. Okay. If you double integrate it, then what you will be getting? What is the range of x? Range of x is 0 to y. Okay. So if you're putting the inner limit, then you can innermost limit, then you can take care of this inequality, which is 0 to y. Okay. First you are, let's suppose, doing x, then this is cy. Okay. Then dx. First you are doing x. And then y is from, now you can see y is from 0 to 2. Okay. Then this is dy. Okay. Tell me, what will be this cy dx? If you're integrating with respect to x, then I think this is just cx, right? So cy is constant actually. So it is just x. Now x is from 0 to y. So it will be, I think, y, right? So it is cy square. So it will be 0 to 2 cy square dy. Now if we solve this, it will be y cube by 3. So cy cube by 3, 0 to 2, which is c into 8 by 3, which means c will be 3 by 8, right? So it is easy. C will be 3 by 8. Okay, c into 8 by 3 equal to 1, and then c will be 3 by 8. Okay, understood how to solve this? If you want, you can just, interchange the limits, which means instead of first solving for x, you can solve for the y. So what is the range of y? It is x to 2. Okay, this cy. Okay, this is the range of y. Okay, so dy and then dx. And then x will be ranging from 0 to 2. Okay. Y is ranging from, you can say, x to 2, and then x is ranging from 0 to 2. Okay. So you can take care of this since there is no y. I mean, once you integrate with respect to y, okay, don't put it 0 to y. Okay. Don't put it 0 to y because you have already taken care of this. Okay. So now what will be this? This c into y with respect to y will be cy square, I think, right? Cy square by 2. And then if you do this, it will be from x to 2. So this will be, I think, 4c by 2 minus minus x square, cx square by 2, right? So this is basically, you can say, c by 2 you can take common, 4 minus x square. That you need to integrate from 0 to 2. Okay, 0 to 2. Then you can do it basically. Okay. So integration over 0 to 2. C by 2 is outside. 4 minus x square. What will be that? This is 4x. This is x cube by 3. This is 0 to 2, c by 2, which should be 1. So 0, for the 0 anyway it will be 0. For 2 it will be 8 minus 8 by 3, which is 8 minus 8 by 3, which is I think 2 8 by 3, right? So it is 2 8 by 3, c by 2 into 2 8 by 3 equal to 1. So from here, if you calculate, c will be 3 by 8. Okay. So you can do in any of the way, you will be getting the same answer. Okay. You can even interchange the limits. So that's fine. So here I can say we are doing y first. Okay. Which means we are integrating over the y first. Here, okay, I think there is some typo. This is c into y, right? This is c into y. So here we are doing x first. Understood? Okay. Now let's just see more examples. Okay, actually this will keep on coming. So let's just move to the next topic, which is expectation. Okay, these double integration will be actually everywhere. Okay, I mean, if you are dealing with the joint distribution, then the double integration will be obviously there, right? Just a second. Okay, now let's just see the expectation. Let xy with a 2D, or maybe, I mean, this is a joint distribution, and if you want to find out the expectation, then like the way we have done previously, you can just put that function into the distribution. Okay, so let's just see the examples here. For example, if this joint distribution is given to you, right, and then they ask you to find out the expectation of x y square, can you try doing it? So let's just do this, right? Let's just do this. So what you can do, you can put, you know, the integration. So you want to find out expectation of x y square. So you can put integration, double integration, which is here you need to put x y square, and then this is fxy, right, which is x plus y. Is this fine to everyone, or there is, you know, hard to understand? See what I'm saying? This thing, right? This thing is actually f of xy, right? And then you can say that if you want to find the expectation, it will be from minus infinity to infinity. I mean, range over all the possible values of x and all the possible values of y. So the possible values of x is given to be 0 to 1, and the possible values of y is given to be 0 to 1. Doesn't matter you are doing x first or y first. Okay. I mean, it doesn't really matter. So if you do this, you will be finding the expectation, right? So let's just see what is the answer we are getting. Okay. So 17 by 72. 72 is the final answer. This rule is called lotus. Why? Because you are finding the expectation of not random variable, you are finding the expectation of function of random variable. That's why we call it lotus. Do you remember this from the module 1? Okay. I think the full form is law of unconscious substitution, something like this, right? Law of the unconscious substitution, something like this. Okay. So this says that if you want to find out the expectation of any random variable, then function of random variable, then you put that function of random variable directly, right? Okay. Now let's suppose that they give you this particular joint PDF, and then they ask you to find out the expectation of x. This is little interesting. Can you try doing it? See, if this could have been x y square or something like this, the way we have done earlier, then it is easy, right? Let's suppose this is x y square, then it could have been x y square fxy, right? But if it is just x, then what to do? So is this correct? expectation of x equal to, is this correct? I can just write x here in the joint PDF also. And then this is from minus infinity to infinity. This is also from infinity to infinity. Is this correct? What do you think? So yes, this is correct. Why? Because why this is correct? Because here, this particular thing, right? This particular thing, isn't it the function of x and y? This is also the function, right? Function of the random variable. Here, you are not seeing y, that's fine. I mean, you can see y power 0 as a function if you want to visualize the y. But yeah, this is okay. This is some function only, right? So you can definitely do this. So if you do this, let's suppose you do this, then you can find out the expectation, okay? You can integrate it. I think the answer is not written here, but you can use the lotus rule again, okay? So it's not like that the x and y must be involved. Okay, that's fine. If x and y is not involved, that's also fine. So let's just do one thing. Let's just try to find out the expectation of x using, we have done it using the lotus rule, but using the marginal PDF also. Do you know that if fxy is given to you, then how to find out the fx? How to do it? We need to integrate over all the possible values of x or y. Should I write dx here or dy here? Yes, all the possible values of y. Then you will be finding out fx. So let's just do one thing. Let's just find out the marginal PDF. And once we have the marginal PDF, then we can find out the expectation of x as integration of minus infinity to infinity x into fx, right? Just a single integration here. Okay, dx. So we can go this way also, which means first find out this and then find out the expectation of x. If you want to, we can go this way also. So let's just see. See, if you want to find out the aspect, this marginal, okay, this is a marginal PDF. Then you can do this, and then this is the answer that you're getting. So the marginal PDF is something like this. And then you can find out the expectation. Okay. Here you are getting 0 to 1 x into x plus 1 by 2. Okay. So here it is not solved, but if you solve this, then you will be getting the same expectation that that you have got here, right? Okay. Cool. Now, let's see one definition. Okay, this is just a simple definition that you might already be knowing. That if you want to check whether two random variables are independent or not, you can check using the PDF. How? That if this PDF can be written as the PDF of x into PDF of y, then we will say that x and y are independent. Okay, just a simple definition, just like the joint PMF. Okay, we used to have the similar thing in the joint PMF also. Cool. Now let's see this question. What this question is saying. If two random variables x and y have the PDF something like this, can you evaluate this k? I think this is easy. You just need to double integrate, and then you can make it equal as um, 1, and then you can find out, right? So you can try this using as an homework. Okay. So if you do this, so actually, this seems to be independent, right? I mean, in the sense that this particular, PDF can be written as some quantity as x into some quantity as y. So you can check it whether it is independent or not. How to check it, by the way, whether these two are independent or not? You can find out f of x. What is f of x? Minus infinity to infinity. This particular thing, right? This is basically e power minus 2x into e power minus y into k. Okay. This is dy or dx? Tell me. This must be dy, right? So if it is dy, this you can take outside and then minus infinity to infinity e power minus y. What it will be? I think this is 1, right? So, so actually this is equal to k into e power minus 2x, right? Why? Because k into e power minus 2x from minus infinity to infinity, e power minus y, okay, dy. Yeah, xy is from greater than 0, so it will be ultimately it will be 0. Yes. So ultimately it will be from 0 to infinity. Okay. So let's just solve it. So it will be e power minus y. So if you put infinity, then it is 0. And if you put, minus and minus will be plus. If you put 0, it will be just 1. So I think it will be k into e power minus 2x. So which means this f of x is k into e power minus 2x. And can you find out the f of y? What will the f of y here? I think it will be k into e power minus y, right? Or maybe I think this will be minus 2y. Yeah. So I think it will be k into e power minus y, or it will be k by 2. So I just need to check. Okay. So let's just find out f of y. It is k into minus infinity to infinity. You can say e power minus 2x into e power minus y into dx. So e power minus y you can take outside, and then you can find out this, right? So this number is coming out to be k into e power minus y integration over 0 to infinity e power minus 2y 2x. Why it is 0 to infinity? Because x is given that it is greater than 0. Okay. So it is minus 2y 2x upon 2, and then this is minus. So it is from 0 to infinity. So if you put this 1 by 2, you can take outside, right? So if you put infinity, then it is basically 0, then plus, I think, 1 by 2. Okay. So it is just 1. 1 or, sorry, 1 by 4, right? No, 1 by 2 I have taken already outside. So if you put 0, then e power 0 is just 1. Okay. This is 1. So I think it will be just 1 by 2. Okay. So it will be, I think, k by 2 or something, right? So k by 2 e power minus y. So what is the value of k? K value is 2 basically. So since k is 2, so it is basically e power minus y only, right? It is e power minus y, and it is basically k into e power minus 2x, or 2 into e power minus 2x. So you can say that here you have k or 2, whatever, right? But here you don't have k. So it is not repeating. K is not repeating. So which means k you can take with, basically you can factor it, and k you can take with fx, e power minus 2x into e power minus y, right? So this is just fx, this is fy. So which means that this particular thing, this fxy, right, uh, is rewritten as fx into fy, which means this is independent. X and y are independent. Okay. Mostly they are independent if you can rewrite it. So basically, in most of the cases, they are independent. If let's suppose this was the case, right? If you can write something, some function of x and some function of y, then mostly it is independent. Suppose if I say this, suppose that fxy is this, xy minus x square, something like this, right? So you can't separate the terms of x, you can't separate the terms of y, which means you can't write something only with x and something into something only with y, right? You can't do this because this is multiplication. Okay, in such cases, generally I can say they are not independent. So this particular function, this particular random variable x and y, in such cases they are not independent. But if you have something like this, where you can write some function of x into some function of y, in such cases generally they are independent. Okay, we have even verified it. We have even calculated fx separately, fy separately. Okay, and then I have verified that they are independent actually. Okay, and then you can find out the value of k also. So we have done multiple things here. We have evaluated k, and we have also check if x and y are independent. Understood? Okay. Now, you already know this. If you want to find out this probability, okay, if the marginal PDF is given, then you can do this. Marginal PDF is given, you can do this. If you want to find out this, then if the joint PDF is given, then you can do this. Okay. Now let's just see something called as joint CDF. Okay. So basically we have seen joint PDF. Now let's just see joint CDF also. So here, let me write it as a joint CDF. Okay. So suppose the joint PDF is given to you. Then CDF, do you remember? CDF is always, this is nothing but probability of x less than equal to a. Always from starting, right? Which means from minus infinity to a, and y is from less than equal to b. So this is f of capital F. Okay. This is capital F of x, y, a, b. Now let's just see some questions. Okay. Let's see this question. So what they're saying, that this is a multiple choice question. They are saying that x is ranging from -2 to 4. Y is ranging from -1 to 5. Then they're asking you that find out this, okay, this probability in terms of the joint PDF, joint CDF. Let's suppose the joint CDF is given to you. Then they're asking you to represent this in terms of the joint CDF. Okay, this is a good question. Do you want to try this? Just take some time and let me know what is the answer you're getting. So what you can do, you can just try understanding this kind of equation, and then it will be easy. So let's just see that using the CDF, how to find this probability, right? So let's suppose x is ranging from x1 to x2. So which means this is the range of x, x1 to x2. This is the range of y, probably, which is, let's suppose, y1 to y2. Okay. Now this is the region in which we are interested in. Now tell me in which dimension the graph of this CDF will be, the joint CDF. Is this the graph of the joint CDF? No, right? This is just a region. Now, this graph of the joint CDF will be in 3 dimension, right? How? There will be one more axis, okay? One more axis, which is telling you this joint CDF x, fxy or something, right? So, okay, let's not worry about it. But yeah, we are actually interested in this particular region, right? So what you can do, if you're interested in this, you can basically take the as they are suggesting. So you can take from the start, which means that you can take this region first, right? This all region. So x is from start and y is also from start. So basically this whole region, okay, which means this is from minus infinity to x2, from minus infinity to x2, and then so basically you can say that from minus infinity to x2, which means this whole region from minus infinity to x2 and minus infinity to y2. So this is the whole region, right? So this is the first thing. The first thing here is that minus the extremist points, right? The upper limits. So x2 and y2. So this is basically minus infinity to x2 and minus infinity to y2, something like this, right? You can take it. And then what you can do, you can subtract, okay, from minus infinity to x1, which means you can subtract this region, okay, and then minus infinity to y2, which means minus infinity to x1 will be uh, this one till x1 and then till y2, okay. So basically this particular region you can subtract this whole region, okay. So how to subtract it? Like this, from minus infinity to x1 and then minus infinity to y2, okay. Now still you need to subtract this much more, right? So which means what is this region? Okay, so you can always take from minus infinity only. So minus infinity to x2, okay. So basically they are saying that you can subtract from you need to also subtract this much region. So they are saying that minus infinity to x2 you subtract, and then minus infinity to y1, okay, to y1 you subtract. So if you do this, then yes, this minus infinity to x2 and minus infinity to y1, you do this, then this particular region will be subtracted once, I mean, two times basically, right? This particular region will be subtracted two times. So that's why from from x1, so minus infinity to x1 and minus infinity to y1, okay. So this region, I think they're adding it one more time. Okay, so let me do one thing. See, let me just try to explain this more clearly. This is where we are interested in, right? So let's just suppose this whole region minus infinity to y2 and then minus infinity to y2, which means this, and minus infinity to x1. Okay, this is the one region. Let's suppose with respect to minus infinity, I'm saying this is one region. What is this region? This region is this region is minus infinity to by 2 and minus infinity to x1. So f of capital F of x1 comma y2, because CDF is always from minus infinity. Okay, CDF is always. So if you want to find out, let's suppose this the individual CDF, then what was that mean? Let's suppose f of a. It meant if you remember x less than equal to a, right? It is always from minus infinity. Okay, it is always from minus infinity to a. So CDF is always from the starting. So with respect to CDF, if I want to find out, then what I'm doing, I'm saying that this whole region, okay, this whole region. So which means from starting to y2, okay, from starting to y2, and then from starting to x1, this is one of the region, which is x1 y2. Okay, so what I can do, I can probably do x2 by 2. Okay, x2 by 2 if I do, and then if I subtract x2 by 2, if I subtract x1 by 2, okay, see here, this is the whole region which is x1 by 2. This is the whole region which is x2 by 2. So if I do x2 by 2 and I subtract x1 by 1, okay, then I will be getting this particular region. Okay, x1 to x2, but by will be actually from, you can say x is from x1 to x2, and then by will be from minus infinity to y2. But we are not interested from minus infinity. So what I'm saying here is that, see, I hope you're getting. It's just a little bit algebra. So this is the whole region, okay, and this is also the again whole region, okay, yeah. So these are the two regions. Now what you can do, you can basically do x2 by 2, which means the complete this whole complete x2 by 2, okay, and from this x2 by 2, you can subtract from this is x2 by 2, you can subtract x1 by 1, which means this one, right? X1 by 1 till this point you can subtract this. If you remove this, then this one is remaining and this one is also remaining to remove, right? So how to remove this one? Only this one. So if you want to remove this one, this is basically for the y, it is minus infinity to by 2. For the x, so it is x1 by 2 basically, right? So x1. Okay, so they are first removing x1 y2. So that is also fine. So see here, this whole region is x2 by 2, right? This is x2 by 2. Okay, this complete box, this is x2 by 2. Now you want to just find out this. So what you can do, maybe you can remove x1 by 2 first. Okay, if you remove x1 and this is by 2, so before x1 and by 2. Okay, so if you remove this, then this is x1 by 2. Okay, this is x1 by 2. So you can remove this, but you also have to remove this particular portion. So what is this portion? This is till x2, right? Till x2. So you can remove till x2 and then by 1, right? So till x2 and y1 you can remove. But if you remove this, then this x1 by 1 is removing twice. Okay, it has been removed twice. So that's why you need to add this once. Okay. So I hope you are getting, but still let me just, tell you one more time. See, just tell me this particular region. So this particular region we are interested in, right? This particular region we are interested in. So what you can do, maybe, okay, just one of the way I'm writing. What you can do, you can do, x2 y2. This is the complete the superset, you can say. Okay. So let's not worry about minus infinity to infinity. I mean, okay, just for the sake of simplicity, let's suppose x and y are greater than 0. Okay. X and y are greater than 0, which means I'm just saying this. Okay. I'm having this much area. Okay. So this whole area, can you tell me what is this whole area? This is x2 and y2, right? This is x2 and y2. So f of x2 y2. Okay. This is the whole area. Now, can you tell me what is this area? This is from starting 0 to x1 and 0 to y2. So this whole area minus f of 0 to x1 and 0 to y2, right? X1 by 2. So this area I have removed from the whole area. Now this one also I have to remove. Okay. This one also I have to remove. So I cannot do x1, x2. So since CDF is given, I have to take from the starting. So what you can do, so you can say this is removed, right? From the whole, this also you have to remove. So what you can do, from start to x2 you can remove, and then till y1. So if you remove this, then it will be removed, but this will also be removed, right? This will also be removed. So basically you can remove till x2 and y1. But since till x2 and y1, so this whole thing will be removed instead of just this one. So that's why I'm adding this again. I'm adding f of x1 y1. Okay. So I hope you understood, or how to tell it even more easier way. So see here, see, let's just have the nomenclature for all of this area. So what is this area? This area is f of, okay, just this area. Just tell me only, okay, just tell me only this area. This is f of x1 y1. Is this fine to everyone? Okay. So only this area is well to do using the CDF. But is this area easy to get using the CDF? I think no, right? You need to find out from the starting. So what you can do from the starting, if you want to find out, so that's why you can say that these both of this area, okay, both of this area, not just one area, both of this area. Can you tell me f of x2 by 1, right? Similarly, can you tell me this area only? I think from the starting we need to find out. So this area only we can't find out. So that's why let's just see what is this area. Okay, both of this. So what I'm saying here is that both of this area and this area, both of this area, can you tell me? This will be till x1 and y2. Yes, this will be f of x1 and y2, right? Okay. And the complete area, can you tell me? F of x2 by 2. So now we need to find out this much only. Okay, this much only. Let's suppose. So this easy now, right? After this visualization should be easy enough. So what I'm saying here is that this is, the complete is f of x2 by 2. If you subtract from this f of the whole area, if you subtract, let's suppose this one, okay, whichever you like, you let's suppose this one, which is f of x2 by 1, then this whole thing is subtracted. Now you need to subtract this also. Okay, this also, but you can't just subtract only this one. We don't have any formula for only this one, so you can subtract the whole one first. Okay, you can subtract the whole one first, which is f of x1 by 2. And then since this has extra got subtracted, which we don't intend to subtract, that's why you can add f of x1 by 1. Okay, is this fine to everyone? That how to find out this particular region, which is probability of, you know uh x going from x1 to x2 and y going from y1 to y2. Okay. Now, given this knowledge, tell me, can you find out this particular? Can you calculate or can you answer this particular question? Do you want to try this question as an homework? Answer is on the next page. If you want, you can try this question as an homework. Let me know. Okay. Answer is on the next page. So this is just a easy. I mean the same question. Okay, the same exact same question. Instead of x1, x2, I have just the values. Okay. This is definitely a potential gate question. I mean, they can definitely ask these kind of questions. Okay, there is nothing. I mean, I can say there is nothing something like that. They can't ask. So they can definitely ask these kind of things. Okay. Now let's suppose this CDF is given to you. Okay, and then they're asking you to find out the joint CDF is given to you. They're asking you to find out this particular probability. How to do it? So x is ranging from 0 to 3 and y is ranging from 0 to 4. Okay. So you can use the same formula, right? Is this fine to everyone? Can you do this also as an homework? Okay. Just try this also as an homework. So see, CDF is always from starting. Okay. CDF is always from minus infinity. So you can't do in between. Okay. For the CDF, it is always from starting. That's why the definition is because it is called cumulative distribution function. Okay. So here the joint CDF is given. They are saying, can you find out the marginal CDF? So if you remember, then the marginal CDF if you want to find out, then uh, what you can do, you can put, see, the joint CDF is basically from, you can say, or maybe let's suppose the joint PMF. If I just tell you the joint PMF, okay, for the joint PMF, what is the formula? It is basically the probability of x less than equal to, let's suppose, some starting value, some value, and y less than equal to b, right? And then let's suppose you are only interested, given this, okay, given this probability, you're interested to find out only probability of x less than equal to a. Then what you will do? What is the value of b? Okay, is this fine that I can do something like this? See, tell me, tell me, is this fine? Which means, suppose, suppose in terms of PMF, I'm telling you first. Now you only tell me. Suppose if I write like this, over all possible values of y, okay? You can take any value of y. Is this same? Are these two quantities same? See, if you say that okay, y can be anything, right? Y can be actually anything. This actually means that y can be anything, right? So in this case, it will be the marginal PMF only. Okay. So which means let's suppose if I give you pxy, if I sum over all the possible values of I, okay, sum over, then you can find out px. Okay. So similarly, suppose if you want to find out the fx, okay, then you put the by as infinity. Okay, these are the values of x and y. You put by as infinity, you will be getting the fx. Similarly, you put x as infinity, you will be getting the fx. If you put both as infinity, which means that x less than equal to infinity, y less than infinity, then obviously it will be 1. Okay. If you put one of them as minus infinity, which means x less than minus infinity, then it is a starting point, right? Then it is a starting point. Okay, so it will be just a starting point, x less than minus infinity. If you put one of them as minus infinity, then it will be 0. Okay, you can also check whether two random variables x and y are independent using CDF also. Okay, using CDF also you can also check. So there are multiple ways to check. Using PDF also you can use the similar formula. Using CDF also you can do the similar formula. Similarly, let's suppose expectation. Okay, so using expectation also you can check. If this is satisfying, then they are independent. If I remember correctly, or maybe this is just one way. I will just verify this. Which means if they are independent, then this is definitely satisfying. But is this the other way also? I will I will verify it if it is other way. Which means if this is satisfying, can we say they are independent? I will check. Okay. But anyway, so is this understood to everyone that how to find out the marginal CDF? You just need to put one of them as infinity, right? So for example, if they ask you to find out the marginal CDF, okay, so what is this fx, f of xy, and then put by as infinity, okay, and then you will be getting fx. So if you put y as infinity, then e power minus infinity is actually 0. Then this is going to be 1 minus e power minus alpha x, right? Similarly, fy will be 1 minus e power minus alpha minus beta y. Okay. Yeah. Are they independent? Is this true that x and y are independent? What do you think? Yes, right. Because this is the first PDF, this is the CDF, this is the second CDF. So yes, they are independent. Okay. Okay. So I hope you understood this joint CDF also, right? Now, let's do one thing. Let's solve this particular question. What they are saying here, the joint distribution is given to you, and then they're asking you to find out these probabilities. Okay. Let's just solve this question. So how to solve this question? Probability of x less than 1 and y could be anything, right? So this is the CDF, oh sorry, PDF only. Joint distribution, if they are not mentioning, it is the PDF. So what do you think we need to do? What is the range of y? it will be from 0 to infinity. And what is the range of x? It will be from 0 to 1. So basically, you can find out probability of x less than 1. Suppose if it is x less than a and y less than b, and what is this probability using the PDF only? It is the integration of the PDF, right? From 0 to a and 0 to b, something like this, right? Okay. But now they are saying just x less than 1. They're not saying anything about y, which means y can take any value. Okay. So if they're just saying x less than 1, can you just calculate what is the answer you are getting? Y can take any value and x will be 0 to 1 only. Okay. You can solve this. Let's just see the answer that we are getting. Okay. They have first found out that I think uh, this marginal PDF, which is minus infinity to 1. X is greater than or equal to 0. So minus infinity is actually 0. Uh, yeah. So 0 to infinity, if you do this, this will be e power minus x. Okay. So this inner thing, this is actually easy. So if you do this, then I think this will be 1. So e power minus x you can take outside. So it will be just e power minus x. And this is just 1. Okay. This is just 1. So it is nothing but you can take this e power minus x outside. So integration over 0 to 1, e power minus x. And the remaining thing, which is 0 to infinity, e power minus y dy. This is actually just 1. And then you need to integrate e power minus x. E power minus x is nothing but e power minus x minus, right? Which is 0 to 1. So I think this is e power 0 is 1. So e power minus 1 plus 1. Okay. 1 plus e power minus 1. Something like this. Or 1 minus. Uh, yeah. So it will be minus. Okay. So this will be your final answer. 1 minus e power minus 1. Understood? So you can do this like either like this, which means you know that okay, this will be bike and range from anywhere to anywhere, or maybe you can first find out the marginal CDF, marginal PDF. So they have first found out the marginal PDF, which is also fine. Okay, which is also fine. I mean, what I'm saying here is that let's suppose it was the joint PDF was this one, right? E power minus x, e power minus y. This was the joint PDF. Okay, zero otherwise. Now, now let's suppose you want to find out the marginal PDF. Then what you will be doing to find out the marginal PDF? Okay, fx equal to, you need to do integration of minus infinity to infinity, or maybe since it is ranging from 0, okay, 0 to infinity, this e power minus x, e power minus y. Okay, dx or dy, tell me. Okay, great. So it is dy, right? If you do this, I think this is coming out to be e power minus x, right? And once you do this, then you can find out probability of x less than 1 like this, which is minus infinity, or maybe since it is going from, I mean, the least value 0, 0 to 1, or minus infinity to 1, right? Fx, which is 0 to 1, fx dx. Okay. And fx is actually nothing but, okay, e power minus x, you can treat it like this. Or maybe if you visualize this fx, okay, this fx was nothing but, in terms of integration, it was nothing but 0 to infinity e power minus x e power minus y, right? So basically it is a joint distribution, right? This was the fx, right? This whole thing was the fx. So you can directly do like this. This is a joint distribution, and first you integrate with respect to y, and then you can integrate with respect to x. So you can find out the marginal one, and then you can do, or maybe let me just write it completely. Okay. So if you first find out the marginal one, and if you do, then you will be getting the similar thing, which is 0 to 1 e power minus x dx, right? This is using marginal. You can also find out this p x less than 1 using joint PDF also. So the value of y will be from 0 to infinity. The value of x is from 0 to 1 because x is less than 1, right? Okay. This is the y. So which means this is e power minus x, e power minus y. This is y. And then this is the x, right? Which is, see, this is nothing but your e power minus x, which is the marginal PDF only. Okay, this inside thing is nothing but the marginal PDF only. So using the joint also, you can do directly, because both are the same thing. It is just that we are doing, you're first calculating this and then you're substituting later, and here you are calculating this using the two integrals. I mean, you're calculating right here only. Okay, instead of saying this explicitly as marginal, you are calculating it right here only. Okay, so both are things fine. Okay, now let's see the next question, where they are saying the what is the probability of x plus y less than 1. Okay, so this is given to you, then they are saying what is the probability of x plus y less than 1. That's what they are asking. Okay, so x and y both are greater than 0. So can you tell me what how to do this? See, do you remember that if x is less than a, let's suppose y less than a, how to, or less than b, then how to do it? From minus infinity to a, and then from minus infinity to b, and then fxy, right? This is the formula that we have. Now they have some other relation. Okay, they are not saying something like this. They have some other relation. Now can you convert this? Okay, can you convert this something like this? Let's suppose if I want to convert, right? Then x is greater than 0. So maybe it is, you can say, from 0 to infinity, x is greater than 0. And if it is greater than 0, then y you can write as y is basically, you can say, less than 1 minus x, right? Y is less than 1 minus x, something like this. Okay. I mean, you need to basically see the relationship between x and y. So you can say that y range, okay, if you want to find out the probability of this, then there will be two integration. Y range will be, it is greater than 0, but till 1 minus x only. Okay, x range is, okay, x range is 0 to 0 to, see, x cannot also vary to infinity, because x plus y has to be less than 1. So basically that x range has to be from 0 to 1 only. Okay, because x plus y has to be less than 1, so it cannot cross 1. Okay, it cannot cross 1. So let me show you that what they have done. See, okay, so here, if you want to find out the probability of x plus y less than 1, then y will be from 0 to 1 minus x because of this relationship. X will also be from 0, it generally it is from 0 to infinity, but it cannot cross 1. Okay, because the moment it is crossing 1, then it will be, the whole summation cannot be less than 1. You need to take care of the summation also. Okay, so basically this is the line where x plus, this is the region that they are interested in. Okay, and x is greater than 0 and y is greater than 0. So So basically, this is the region they are interested in, right? Which means, x plus y has to be less than 1. See, x plus y equal to 1 is this line, less than 1 is this region, greater than 1 is this region. Okay. So equal to 1 is this line. And if x and y both are greater than 0, then this is the region in which they need to integrate. Okay. So the integration is for this region. Tell me, is this the integration of this region? Is this the integration of this region? Okay, maybe I'm confusing you, but just understand my statement. Is this the integration of this region? No. For example, let's suppose if it is if it is just 1D, okay, then we say x is ranging from 0 to 5, let's suppose, okay, and this is fx, okay, let's suppose this is fx, and we found out the area under this. Is this the integration of this range of this region, this 1D? No, integration of this fx. Integration is not for the range. Okay, which means this is the integration over this area, which means this is just a range. Okay, integration over this we need to do. And integration of what? We will be doing integration of fxy, which is a 3D graph, right? Which I can't show you, but you just understand that there will be a 3D graph of which I want to integrate. Okay, anyway, like what I'm saying here is that let's just understand the region on which I want to integrate. Okay, this is the region, I can say this is a region on which I want to integrate. I want to integrate of what? So this region is basically, what is this region? Y is ranging, you can say y is ranging from 0 to 1 minus x. So you have taken care of this. Okay, y is ranging from 0 to 1 minus x. And x also can't cross. Okay, x also can't cross this one. Okay, x also can't cross this one. So x is ranging from 0 to 1. Okay, this is a region on which I want to integrate. Understood? So this is the limit. So the only part here which needs to be understand is the limit. Once you figure out the limit, then the rest calculation is okay. Okay. So see the region. Okay, you can draw the region on which you want to integrate, and then see that what are the ranges of x and y, such that this particular condition doesn't violate. Okay. Cool. So this is the region basically. And the rest of the calculation you can do. Okay, it's not very tough. It's easy only. Now let's suppose they ask you to find out the expectation of exy. So how to do it? I think we have already done this kind of thing. 4xy. This is double integration from 0 to 1 and then from 0 to 1. Right? Is this fine to everyone? This is lotus rule, right? This is lotus rule. Okay. Okay. Now, let's suppose they say that the random variable, the joint distribution, joint density is this. Then they ask you to find out all of this. Okay, all of this. Do you want to try this particular question as an homework? Okay, I have solutions on the next page. If you want, you can just try this as an homework. Okay, almost everything we have studied, just try this as a homework. Okay, try your best. See that how to see this. Okay, how to calculate all of this. We have studied all of this. Okay, you just need to figure out that how to do it, in the sense that just apply whatever you have studied and then just figure out all of these quantities. Okay, so answer is on the next page. You can definitely verify later on, right? Okay, so similarly you can try this also as an homework, and answer is on the next page. So there are few quantities, there are few questions. Do you first want to try yourself? It might take 2 to 3 hours, okay, because this is the very first time you are studying. So just try all of this, okay, all of this as an homework, and then we can do one thing. We can solve all of this in the next class. Okay. So these are the good questions. Just try. Okay. All of this is an homework. First you try, and then we will be doing all of this in the next class. Right? First you try. Okay. This. Okay. This one. Answer is on the next page. Don't worry. And then there's a gate DA question which they have asked this year. You can also try this if you want. Okay. This is also not a very tough. This is also easy question only. Okay. So you just try all of these questions, and then we will be having one more session to solve all of these questions, including some extra questions. Okay. And then this topic will be over. Understood? And then we will be just finishing this topic, and then we will be starting a new topic after that. Okay. So that is all I wanted to convey today. So thank you, everyone. If you have any doubt, you can just let me know. Okay. So thank you. Thank you so much. Just try all of these questions. Okay. Thank you. Take care.